In this lesson, we're going to talk a bit about how we can prepare solutions in a lab, because that's one thing that all chemists need to do, and other scientists as well, is be able to prepare accurate solutions that they can then use to carry out reactions and other experiments. So what they're trying to create is a standard solution. So this is a solution with a known concentration, an accurate concentration. And there are two ways that these standard solutions can be prepared. So you can measure out a mass of the pure solute and then dissolve it in an accurate volume of water. Or you can take a stock solution, which is a solution with a high concentration, also accurate. So you can dilute that solution by adding an accurate volume of water to it. Now the question comes, well, how can you get an accurate volume of water? So there are various types of lab glassware that can be used to measure volume, but they all have different degrees of accuracy. So it's important when you're creating a standard solution that you use the correct kind of glassware. So you're probably familiar with beakers, but these are really not accurate. They have graduations on the side to tell you an approximate volume, but this is not the type of glassware you would want to use for making a standard solution. Erlenmeyer flasks, which you've also seen, are also not accurate. Graduated cylinders are more accurate than beakers and Erlenmeyer flasks, but still are not likely accurate enough to create a standard solution. Volumetric flasks are a piece of glassware that are used quite regularly to create standard solutions, and this is because they are very accurate. They measure a specific volume, so you have different sized volumetric flasks, some for 10 milliliters, 50 milliliters, 100, 250. It keeps going, 1 liter. And so there's a graduation mark on the neck of the flask that shows you where that volume is. And you can, using a dropper, get the solution right to that line, and then it will be very accurate measurement of volume. Pipettes are also very accurate. They measure smaller amounts. They can be a volumetric pipette, so they measure a specific volume, or they might be graduated, like a graduated cylinder, and be able to measure different volumes. Micropipettes are also very accurate. These are for measuring very small volumes, so in the microliter range. They have disposable small plastic tips, and they kind of suck up a very small volume, but they are very accurate also. And finally, burettes can be used to measure volume. They're generally used in a procedure called a titration, and we'll talk about that more later in the course. So if you were going to create a standard solution using a dilution, you would take a stock solution, and that's a solution of a known high concentration. And it's not usually used straight because it's too high of a concentration. So it's diluted with water before it is used. So when you're diluting a solution, you're adding more solvent. You're not changing the quantity of solute that is present. You're just adding more solvent. So the moles of solute that exist before dilution are the same as what is there after dilution. So if we take our equation for molar concentration, which is that N equals C times V, we can sub that into the equation. So N1 is equal to N2, so we can say that C1 V1 is equal to C2 V2. And this is the dilution equation. So our first sample problem. Your teacher has a stock solution of 12 mole per liter hydrochloric acid. A class experiment requires 2.0 liters of 0.10 mole per liter hydrochloric acid. What volume in milliliters of concentrated solution should be used to make the dilute solution for the experiment? So in this question, we have our first concentration, 12 moles per liter. And we need to find the volume of that solution that is needed. For our standard solution, we want to make 2.0 liters, and we want the concentration to be 0.10 moles per liter. So C1 is 12 moles per liter. We're trying to find V1, and we want it in milliliters at the end of the problem solving. And then we have C2 and V2. So a note about units when you're doing these dilution questions. C1 and C2 have to be the same unit, which will be moles per liter, and V1 and V2 need to be in the same unit. So if you already have one of the volumes in milliliters, the other one will come out in milliliters. In this case, because V2 is in liters, when we use the dilution equation, we'll get V1 in liters and then need to convert it to milliliters. So there's our equation, C1V1 equals C2V2. We're going to rearrange for V1 because that's our unknown. So we get C2V2 divided by C1. I'm going to sub in the values. Moles per liter cancel, and we're left with the unit of liters. When you calculate that out, you get 0.017 liters. The question wanted the volume in milliliters. So you times by 1,000 milliliters in 1 liter. So we get that 17 milliliters. So if you're going to create this solution, you would need to take 17 milliliters of the stock solution, and then you would put that into a volumetric flask of 2 liters, and you would add water up to the point of 2 liters. In the next sample problem, a solution is prepared by combining 50 milliliters of a 3.0 mole per liter solution of iron 3 nitrate with 450 milliliters of water. What is the final concentration of the solution? So we've got one volume, 50 milliliters, and one concentration. Then we have another volume, but it's important to note here that this is the volume of water that is added. It is not the final volume of the solution, which is what we need to do the calculation. So C1 is 3.0 mole per liter and V1 is 50 milliliters. C2 is what we're trying to find, and V2 is the 450 plus the 50. So the total volume of 500 milliliters is what we'll use in the calculation. So C1V1 equals C2V2. In this case, we're going to rearrange for C2. So we get C1V1 divided by V2. We're going to sub in the numbers from the question. Notice that milliliters cancel, and we're left with mole per liter, which is what we would like because we're trying to find a concentration. So when you do that calculation, you get a final answer of 0.30 moles per liter. So that is the final concentration of the solution. So that is how we can use a dilution equation to figure out how we can prepare standard solutions in the lab.